Okay, so we're going to take a look at our 9.3 lesson, which is exponential functions. Okay, now exponential functions come in a lot of formats, but the most generalized format is this: y equals ab to the x. We call it exponential because look at where the variable is. The variable is an exponent. Okay, the variable here is an exponent. Okay, and the variable here is an exponent. Right? And what we're trying to determine is the power of exponential growth. Okay, so the larger this number gets, okay, the more rapidly the whole function changes. And the smaller this number gets, you're going to see that how rapidly the function changes over time. Okay, so first, a nice example that I wanted to look at first is, let's say we take the number 10 and we wanted to increase the number 10 by 12%. Okay, so if I take the number 10 and I wanted to multiply the number 10 by 1, I've got 10 times 1 is 10. Now, if I wanted to increase it, I can do plus 0.12 because that's 12% as a decimal. So if I go 10 times 1.12 on my calculator, I'm increasing 12%. And you can see what's going to happen is now it's going to go up to 11.2. Now, if I wanted to do that again, what I could do is I could take 10, I could multiply by 1.12, and then if I wanted to increase it by 12% again, I could also multiply by 1.12 again. All right, so I would do 10 times 1.12 times 1.12, and now you're going to go up to 12 or 12 whatever, 12.544. Okay, so you see what happens here is now what I could do is literally rewrite this as 10 times 1.12 raised to the second power. Right? And you see you're going to get the same answer. So this is what makes it an exponential function, right? Notice that the exponent now is up here as 2 because it's just repeated multiplication over and over and over again, okay? So the important lessons here, again, reminder, we're trying to teach you all to be educated consumers of information. So two examples, and there's many different examples that we're going to look at, but two examples that we're going to look at is one, let's say that you buy a pair of $250 Jordans with a credit card, and the credit card gives you an 18%, meaning that you have to pay them back at a rate of 18% of the money over a year. Okay, so let's take a look at it. For example, after the first year, let's say you don't pay the credit card back. All right, we're going to get a value here, our money here. Okay, the value of our $250 is going to be $250. Okay, they're charging 18%, so you're going to say 1.18, and then to the first power, that will be after the first year. So I'm going to go 250. All right, 250 here. Let's clear everything out here. 250 times 1.18, and if you don't pay the credit card company back after a year, right, that cost is now $295. Okay, so the price of your Jordans that you bought is now worth $295 if you don't pay your credit card back in a year. Okay, let's say you forget about your credit card. Let's say you use your credit card and then you buy the pair of Jordans, and then you say, oh man, I totally forgot about this. You're not checking your email, you're not checking your mail, and you forget about it after 5 years. All right, so now I'm going to raise it to the fifth power. So now my $250 pair of Jordans that I owe, right, at 18% interest, now I'm going to raise it to the fifth power. So now that $250 pair of Jordans, if you don't pay it off, is now, whoa, look at that, $571.94. That's how much you would owe the credit card company. So credit card companies are good to build credit, right? But bad if you're not paying attention to it. Now let's even look at it like this. Let's say, oh man, you didn't even forget about this. You went and traveled the world for 10 years and you come back to the United States and this credit card company says, okay, you owe us a bill. What do we think? How much is that going to be now? All right, 1.18, okay, raised to the 10th power. So after 10 years, look at that. Okay, so now you would owe the credit card company $1,308.49. Okay, so you can see that. Look at the power of this growth here, right? This is the first year, this is the fifth year, and this is after 10 years. Look at the difference here. 295 goes up to $1,308.94. Okay, so you can see how exponential growth, how credit card companies make a lot of money by lending you this original $250, right? They're going to give you the original $250 to buy those pair of shoes, right? But they're going to say, hey, you're going to pay us back 18% interest. Okay, so if you're not on top of your game, right? If you're not on top of your financial game, you can see how exponential growth can really put you in a financial hole here. Okay. Another way to look at exponential is what's something that's called depreciation. Okay, so when you buy a car, immediately when you buy a car, right when you drive off the lot, the car is going to depreciate, meaning it's going to go down at a certain rate, and it usually goes down at a percentage rate. Okay, so this time what we have to figure out is if our value of the car starts at, okay, we just bought a car, it is at $10,000. Okay, so notice we're always starting with a value, right? So now what we need to do is if it depreciates, the car value is going to go down. So we're going to subtract 0.175. Okay, so notice that we're not putting 17.5% in, we're putting the percent as a decimal in. Okay, so if I want to figure out what that is, I would take 1 minus 0.175. And you're going to see that if I rewrite this equation, now it's going to be like this, 0.825. So notice this number here is smaller than 1, right? This number here is now smaller than 1. So that means the value of the $10,000 is going down. Okay. Now, what do we want to look at? We want to look at, well, let's see what the value is. You've had the car for 5 years. You want to resell it. Okay, nothing bad's really happened to it. So we're going to type in the number 5 and we're going to see the value. So I'm going to do 10,000 times 0.825, and then I'm going to raise that to the 5th power. Okay, let me go back here. Whoops. Okay, I want to make sure that I have a parentheses in here. Okay, so I've got times 0.825 raised to the 5th power. So the car now is worth $3,000. Okay, so you bought a $10,000 car, and in 5 years, it's worth $3,821.82. Okay, so you can see that exponentially, right, things change very fastly as time increases, right? So you have a $10,000 car, and then in 5 years, right, it's only worth $3,000 car. Okay, so these are two very true life applications that we're going to look at here to try to determine what values of cars are, the values of credit cards, and also the values of savings. Okay, right. The last one I kind of wanted to show you is what happens with our doubling penny problem. Our doubling penny problem. Okay, so let's say if I want to come up with a function that represents the doubling penny problem. And what that means is here, the value of the money that you're going to have is, look, we're starting with a penny, and then we're doubling the penny every day. Okay, we're doubling the penny every day. Okay, so you can see here in our function, if I do 0.01, I'm doubling the pennies. That's the growth rate, right? So this represents the growth rate. Okay, if I look back up top at our original equation right here, this B value, right, this is the growth rate. Okay, so if I'm doubling that penny, I'm going to raise it to the X power. You can see here, if I go to a table, I'll go check out our table here. You can see here, at first, right, we're not really getting a lot of money for the first week, right? Okay, and then what happens here is after the first week, I'm going to get $1.28. But now, if I keep doubling this penny, and I keep doubling this penny, look what happens after 30 days, okay, you're going to get $10 million, right? After 30 days, you're going to get $10 million. Okay, so that's very, very, very powerful. After 30 days, if you double a penny every day, look, it starts real slow, and then eventually it gets up to $10 million. Okay, so graphically, what does that look like? Exponential growth, right, is going to be a value that's going to be slowly starting, and then it goes up really fast. So the graph of an exponential function looks like that. Okay, this is why you can get in trouble financially with credit cards, because if you don't pay off your credit card and you get up here, those values become very expensive, right? And then if we look at the opposite one, depreciates, this is going down. So the car value goes down really quickly, right? So you buy a car here, right? It goes down really quickly. It goes down really quickly. Okay? All right? So this is an introduction to exponentials. There's a lot more that we're going to talk about here. And if you need some help with the compounding formula or the PERT formula, you'll see this in some of the delta math practice. Okay, the value equals the principal times e raised to the r times t. Okay, e is a number on the calculator. It's just a number on the calculator. It represents a very specific number, a very specific irrational number. Okay? All right, y'all. Hope this helps.